Hi, I'm Umair Ejaz from Visual Components. We offer simulation solutions to manufacturing industry that help them maximize their productivity and streamline their operations and improve their process efficiency. I work as a product marketer, and I have a couple of colleagues here with me, Yana from sales and Jouni from technical experts team. Today we are having a discussion about the changing industrial dynamics in the past year, especially in terms of digitalization and how simulation helps to adapt to more digitalization for future business growth. If you are linked to manufacturing or automation industry, this session is going to be very interesting for you. We are going to talk about the following points today. Simulation for digitalization of manufacturing systems. Second, using simulation to stay cost efficient when you're adapting to customized production. And how to use simulation as a primary project communication tool. In the next 20 minutes, we will chat about these topics. My colleagues here will share their observations from the industry, and we are also going to show you how you can use simulation for your benefits. Moving on to the first topic. Now, we know in the past year, several companies are pushed to invest more into the automation and digitalization. Digitalization not just affects manufacturing industry in certain processes, it has its impact in many different operations. It could be from process design, product development, logistics, packaging, and the manufacturing process itself. Now, the main question here is, how do manufacturers respond to this digitalization trend? Is it an opportunity, or does it bring more challenges to them? Let's ask Yana about her thoughts on this one.
Thank you, Umair. It's a very good question, and if we think about the digitalization in the production, we typically refer to the change of how the products are designed, developed, and also the manufacturing process itself. So we talk about the switch to a so-called smart manufacturing. And this switch can create both challenges, but also opportunities for the industry. And often when we move to this smart manufacturing to being more agile, there is a need in increased automation. And this can be a challenge for a production company. And if you think traditionally, manufacturers, they rely on automation providers, on external system integrators to help them plan and design automation. So in other words, they basically rely a lot on an external party and depend on it.
Right, we've touched the challenges now, but how do you think we can help the manufacturers here?
Well, I would say we can turn this challenge into an opportunity. So if you think why manufacturers not so often design and plan production themselves and why they go to the integrator, it can be simply due to the lack of proper tools and resources. And we, Visual Components, as a simulation provider, can give them the easy-to-use tool for production planning and optimization. So now our integrator can do this work inside the house and not fully depend on someone else from outside. And if we go to the slides, I would actually have a good example about that. So this is from one of our customers. It's a well-known company, Kone. They make elevators and escalators, and they also used to make decisions on automation based on the requirements from a supplier. So basically, the supplier would tell Kone what they should invest in, and then they would spend hundreds and thousands on some equipment, and not always they would reach the results that they hoped for or they were promised. So they wanted to change the way they work, and they decided to switch to simulation. So nowadays they have the ability to simulate the changes first in the virtual world, and only after that they tell the supplier what they want to buy. So they have the knowledge inside of the company, and they are also able to make informative decisions themselves based on the real data and not on the crystal ball.
Thank you, Yana. I'd like to ask Jouni now, since he's the technical expert. Jouni, could you please explain the process of creating the simulation models, and also tell us, is it a time-consuming process?
That's a great question, and I believe it's better to show the video and go it through. So a typical design starts by importing a 2D CAD file as the floor plan, and then building the 3D world on top of it. The 3D world can be created by taking measurements from the floor plan and utilizing the parametric models in our e-catalog. That is actually a collection of more than 2,500 components. Okay, I think the video is a little bit on behind, so let's check. So here we actually utilize the components from the catalog. Or like with the 2D CAD file, as we brought in as the floor plan, we can import 3D CAD models directly as components, and currently more than 20 different CAD formats are supported. To add the interactive parts to the layout, we use process modeling, building the layout piece by piece, bringing different components into the layout, like feeders that create the products or raw material into the simulation, process points, stations, and machines. Most components are connected together with the plug-and-play functionality. The processes can be simple pick and drop of points or more complex processes like manual stations or machines. Resources can be almost any type, such as human operators, mobile robots, or forklifts. The controllers are connected to one or more resources and function as a sort of fleet manager for the connected resource. And in the case of robot arm, it can generate a robot program dynamically run time and operate the robot autonomously and use connected tools such as grippers. The process modeling is based on defined product types and flows. The product type visualization, it can be based on existing component, or it can be based on a CAD model. A flow defines the sequence of processes that one or more product type must visit. And the transport links between processes define the means of getting from process to another. What happens inside the process is defined by a set of statements working as the execution logic, basically. So statements are used to request basic or specific product types to be transported in, requesting a simple pattern of products, or spend more processing time, for example. More complex pattern can be defined in assembly editor to gain further control of the assembly order. Typically, the simulation is run while building to check and, check any misalignment or other problems such as reachability. And once everything looks okay, the building can continue. The conveyor library is a good example of easiness of use, thanks for the plug-and-play functionality and automatic property inheritance. Like adding a mobile robot to the layout is exactly the same as any other resource type. So we add the controller and the resource and define the links. Attaching other components, such as top modules, is possible, of course, and defining the transport location on top of the mobile robot as well.
Right. After the concept is done, how do you control the details, like, for example, robot programming or these kind of routines?
The robot arm in the machine tending cell moves automatically. It is also possible to manually program the robot and create routines. In the simplest case, programming is used to reach the idle or the home location for the robot when no actions are required.
It's starting to look like the model is already in the finishing stage. How about we add a different machine to it?
Well, yes, once your cell is actually finished, you can just select all the components and copy and paste the whole cell and then connect the cell into the flow like in any other way.
All right, and Jouni, the simulation already looks pretty nice and very impressive, but how can you get the performance of the line? Can you get any data out of it?
Yes, we can also check that from the video. So in there, all the statistics are based on the dashboard, what we provide for you to create the charts. So most of the components come with the statistics gathering out of the box, and any of the parameters can be set up for monitoring. We have also some smart helper components that can be used to collect data on passing products and to generate a charge for us, like time tracking point that measures the cycle time and lead times. Many times the utilization rate of a resource are important, and one of the KPIs to detect bottlenecks. And obviously the same applies to processes like the machines. Any changes made to the layout, like product feed rate, is reflected to the statistics. Finally, the statistics can be exported to Excel spreadsheet or read via our Python or .NET API.
Okay, thank you.
Interesting stuff. So we've covered the manufacturer side now and also the simulation modeling. How about if we take the system integrators into account as well regarding the digitalization? How important do you think, Yana, is it for them to adapt to this trend?
Well, I would say it's extremely important for them also. So the integrators, they need to be able to react to the changing dynamics in the industry. And actually what I hear from our customers and what I notice myself is that simulation has become a requirement already at the very early stages of the process. So already at the pre-sales, the manufacturer is expecting to see the simulated model added to the quotation. And basically the customer wants to see how the offered solution is going to fit in their current factory and also how it's going to affect the overall production. And of course, for the integrators that are able to provide these simulation models, well, it's a big opportunity for them.
Thank you, Yana, for this insight about digitalization for manufacturers and also for the system integrators.
Sure.
Let's move on to the next topic now, which is one of the mega trends these days called individualization, or some may refer to as customized production. I believe this has been around for years, but it has surely taken up much more space in the recent times and definitely comes with various challenges. I'll ask Yana here, what kind of challenges have you seen production industry while scaling up their customized production?
Yeah, well, I would say the main challenge is to stay profitable. So if you think the main purpose of any business is to be able to generate profit, and the need for individualization pushes companies to change their standard production line to be able to create customized products. And it means that they need to become more flexible, they need to be more agile and keep their costs low at the same time. And again, this is a challenge, and this kind of task requires proper tools. So with the help of simulation, or at least individual components, it is extremely easy to make this kind of changes to the standard production and test how they are going to affect your line, and in order to create these customized products.
Thank you. Jouni, can you help us visualize how we can make modifications to adapt to this customized production, since we already have a model with us?
Sure. Let's bring up a video again, and let's take the example and use the previous layout made. So imagine a scenario where we need to add a new product to the portfolio. We soon realize that it requires some additional processing after the machining. So we add the product type and use the same feeder, but this time use distribution between the existing and the new product type. So now 25% of the created products are the new type. We add the new dedicated machine to the other cell for that new product and try to fit the machine in and moving the whole cell in order to utilize the room between the pillars you can see there, defining the machining time and connecting it once again to the flow. So this time the new flow group actually was created since the product is not following the same flow as the first one. The additional processing must be done manually, so we add an additional conveyor there that will bring the machine product back out from the cell for the human operator. Then renaming the process as studying the reach for the robot to drop point on the conveyor. That can be done with visual aids or by trial and error when the robot program and the simulation has stopped due to unreachable position. Detecting those scenarios is crucial, without a doubt, and one of the reasons to simulate in the first place. So in this case, we just placed the robot with the visual aid. Then adding the new process there, the manual process. We also want to palletize or do the packaging of the new product separately. So a bypass route to the main conveyor line is required. So we connect the two conveyor lines together with the shuttle conveyor. Finally, defining the process in the beginning of the bypass line, defining the statements like we did before and the pattern that we want to create into the container. And then we have the line there. And as a last touch to the concept layout, dedicated pathway areas are used to guide the mobile robot, plus a charging and idling location where the robot navigates to wait and charge the battery.
Right, looks pretty simple and logical to create to make any changes to this created layouts here. Right, let's move on to the next topic now. We've talked about use of simulation for digitalization, and also we touched the mass customized production. But now, once we make the changes to these layouts, how we need to know how to use simulation as a primary communication tool. Now, Jouni, would you be able to tell us like how can we use simulation as a communication tool?
That's really important again. So if you have a look on the videos, what we can export to, we have a number of exporting and sharing options. A 2D drawing with dimensions and bill of materials can be exported. That's a PDF or DVG or the XF. Exporting to animated 3D PDF. We have our own animation file format that anyone can open and view with Visual Components Experience application. The app is also available for mobile devices. On desktop, the same app can be actually used for virtual reality and furthermore streaming in real time from the simulation to another desktop running the experience. That actually enables also interaction with the simulation world in VR. Last but not least, we do have partner solution hosting conferencing over the internet in 3D or VR, where the host can run and edit the simulation while others can observe, point out locations, take measurements, while having an audio enabled between the participants, of course.
Yeah, that's actually very nice, and I do agree that it's extremely important to be able to communicate your ideas clearly and also to be able to engage people so that everyone understands what is the new process, what are the changes that are being made. And actually, Jouni, if I may ask you one more question at the end. So now when we have this nice and impressive simulation model, so how can our users get the most benefit out of the effort and the time that they have spent building this model? Can they utilize the layout any further?
I believe, Yana, you are referring to virtual commissioning, and that's actually a very interesting and hot topic. We do have connectivity capabilities with numerous protocols. So once again, let's take the shuttle conveyor from the layout we used as an example. If we wanted to validate our PLC logic with that, we could start by isolating the problem and set up a simple test scenario in a separate layout and connect it to a PLC via OPC UA, for example. And after validating, we can easily load that same setup into the main layout and replace the shuttle there. Or alternatively, we can set it up in the main layout by adding the necessary sensors, motors, and that control each conveyor individually by on-off signals. Then disabling the internal logic from that shuttle. Then we actually are going to use, in this example, an emulated PLC that is running on the same host machine. The signals and servo values are connected to the PLC by mapping them. This can be done also by importing the config as an XML file. After mapping, we run the simulation with the good warm-up time until the point we are interested in, and run the simulation with the real-time speed factor 1 and see how it goes.
Okay, that's very interesting. So we can basically validate our project first in the virtual world before making any changes in the actual shop floor and the implementation.
Exactly, to get rid of all the logic errors you might have.
Yeah, that's true. That can save a lot of headaches at the end. And you mentioned that we can connect through OPC UA. Is there a possibility to use any other protocols?
Yes, we have connectivity plugins to WinMod, to CMIT, to Beckhoff ADS, and Siemens Step 7 protocol is also supported at the moment.
Okay, great. That's really cool stuff.
Great stuff. Especially one thing was impressive about VR and VR-related solutions is it's very easy to communicate the plans with stakeholders when they are not available on site and working from remote locations these days. Right, with that we have to wrap up our discussion here. Thank you everyone for watching. We hope this was an informative session for you and you were able to see the value of simulation for digitalization and customized production. If you're interested to digitalize your processes, whether they are from production management or it's about getting quotations quickly for sales acceleration, log on to our website today and click that Get a Demo form. Once you fill up your information, our sales reps will help you learn about the use of simulation for your use cases. That's all we have for now. This is Visual Components signing off from this session.
Thank you.
Thank you.